folks just to let folks know about what this project is about and what we're up to. So we've met with a number of different agency groups. We're now starting to give presentations at, for example, the Hawaii Leeward Planning Conference. There's a number of landowners that are there and a number of other areas. So our efforts at this point are to get out into the community and let them know about our project and what we're focusing on. So what I want to do now is just switch gears a little bit and talk about our project and focus on this for most of the talk, and then I'll come back again to kind of our community interactions at the end. We have really 4 overarching goals in our project. One, first and foremost, is to develop new conceptual models of aquifers. And our 2 study sites, which I'll show you in a second, are the Pearl Harbor aquifer and then also the Hualalai aquifer, mostly focusing on Keauhou. So really gathering new data and putting that together into new and hopefully improved conceptual models of these important aquifers. Secondly, we're going to create a resource for data modeling and decision support. And that's basically creating, I'll describe that more, but creating a resource that will be available to the community that will house data, house tools, and we will develop decision support tools for community use. As part of our workforce development and our education efforts, and these will be led by Barb Bruno, we're establishing learning opportunities for students at multiple levels. So we will have undergrads, grads, postdocs, all deeply involved in the research and also in a number of professional development opportunities. So this is a great opportunity for any of your students or grad students who want to get involved in this project. I think it would be a great experience for them to be part of a very large kind of multidisciplinary team-driven project. Finally, the workforce development, really we're focusing on building workforce in 2 areas, in hydrology and also in data science. And that is work that will take place both here on Manoa and then also at Hilo. And a big part of that workforce development is the hiring of new faculty and new expertise at our 2 institutions. So overall, some of our driving questions, we're really looking to gain a better understanding of where groundwater originates, where it flows and where it discharges, and also to study the effect that subsurface geological structures have on the storage and movement of water. Here's our 2 study sites, should be familiar to most of you. Let's see how it works. This is the Hualalai aquifer, this is the Keauhou aquifer where we're going to be doing most of our studies, and then also the Pearl Harbor aquifer. We recently went through a strategic planning session with the NSF leadership who was here, and as part of that strategic planning workshop, we came up with a number of driving science questions. This was a team effort by all the folks on the science team, and so these are some of the questions that we're interested in. The first 3 are really focused on the Pearl Harbor aquifer. The last 4 are focused on Keauhou. And so most of these questions are really focused on trying to understand really some basic things. How much water do we have? Where is it located? How does it flow? And how does it discharge? And so really focusing on the structure of aquifers, their flow properties, and how some of the subsurface structures may either improve or retain water in different areas. I won't go through those in detail, but now, and I would expect that when, for example, when Nicole Loudsey gives a talk on this, she will go through these questions in detail and really talk about the geophysics and the geology underneath this. So what I'd like to do now is just quickly go through the goals of our proposal and then give you some examples of the types of data that we're going to collect, the types of approaches that we're going to use, so you get a better idea of how this whole project is going to come together. So the first goal is to develop these new conceptual models, and there's 3 different techniques that we're going to use, 3 or 4 different techniques that we'll use to try to build a better conceptual model and specifically understand more about the subsurface hydrology. The first will be to use a number of geophysical techniques to try to look at the subsurface, image the subsurface, and get a better idea of those structures that are under there. The second is really to construct a model of flow and connectivity to integrate geochemistry data, biogeochemical samples, I'll talk about that more later, and also submarine groundwater discharge from specific transects on Hawaii Island on Oahu. Here we're trying to understand what is the pattern of water flow, where does it come from, does it cross aquifer boundaries, and that will be a collaboration between the folks that are collecting the data and also Ali Al-Qadi and the folks that are doing the modeling. The third technique that we'll use is to actively monitor wells. So this is a technique that's used a lot in the agencies, but we have some really interesting and innovative ideas about how we may be able to monitor these well parameters with sensors that will be designed by David Garmeyer and his group in engineering. And I have some pictures. So these are just a couple of examples to illustrate the type of data. On the left is some magnetotelluric imaging that was done by Don Thomas a couple of years ago now. This is the Humaula saddle. So this technique allows you to see resistivity of different types of rocks with a passive, by measuring passive electrical currents that come from the earth. So this is a technique that we would like to adapt in different areas of our study sites to try to get an image. Hopefully, this is just a 2D image, but hopefully a 3D image of the different structures that may be impeding water flow in certain areas. The second illustration there is actually from a paper by Delwinoki in 2005, which shows I believe a conceptual idea or conceptual model of the way in which water may flow through the aquifers. Areas where it may be retained and flow is reduced, say in the Schofield Dam area, and others. So the outcome of this part of the project will be to gather data that helps us improve our conceptual models. We're really interested in using geophysics and also in using geochemistry. And one innovative new technique that we're going to try, and this is going to be done by Kiana Frank, who will be a new faculty member starting in PBRC soon. Kiana is a microbiologist, and so she's very interested in the distribution of microbial communities throughout particular areas. And as we do our well sampling methods to sample different chemical compositions of water samples, she will also take samples of the microbes that she finds in those wells. And what we're hoping then is to have, in addition to understanding more of the characteristics of the water in the wells, to have basically a map of the microbial communities in these different areas. And we're thinking of that as almost like a kind of a biological tracer that might be able to help us understand where these areas are connected and where they're not. These are just some other pictures of these. This is also a figure from Delwinoki's paper in 2005, and this was the results. I'm showing this as kind of an example of what we might like to do slightly differently. What this shows is a bunch of wells, and I believe it's USGS and CWRM and Honolulu Board of Water Supply all went out at the same time in the morning, and all measured water levels on all the wells simultaneously. And in that sense got kind of a more global picture of water levels in different areas. Now what we're hoping to do is, this is a schematic design of a sensor that David Garmeyer is building, or a set of sensors that he's building with his students. And the idea is that we will attach this. I'm going to look at this a little closer. Basically, the sensor is actually on a little cable that will go down into the well, and those sensors can then be configured to measure a bunch of different things. They can measure salinity, pressure, temperature, flow rate, acceleration, turbidity, and organics. And the idea is that these sensors would sit down into the well and would stay there and would be able to transmit. They're also, I believe this is a little solar-powered everything, so they'll be autonomous in a sense, and then transmit their signals about those different sensors to, hopefully through a wireless network, and then stream the data back to our data repository. The idea there is that if we have access to and can instrument a number of wells, this may give us the opportunity to have almost like a real-time monitoring network for these kinds of, for these different things that we want to measure. This is a picture of Henrietta Dulai's subterranean groundwater discharge buoy that is, I believe it's out in Kiholo Bay. We're getting one more buoy, Kevin? Two more buoys? Two more buoys. And we'll put those in the Keaho Aquifer area there to measure subterranean groundwater discharge. This is important for a number of reasons. One, it's part of the water budget. This is water that actually leaks out and goes into the ocean, isn't picked up by wells, and also is important not only in trying to understand the whole water budget for a region, but also plays a really important role in terms of the ecology, the coastal ecology. So the mixing of both the freshwater and the saltwater in these areas is really important to maintaining the organisms of those areas. So for this part, for the well monitoring, so Kiana will be measuring her microbial, the microbial communities in a bunch of wells. David Garmeyer's group will hopefully instrument a number of wells, and then we'll also have Henrietta's buoys out in the ocean measuring the SGD levels. And all of this information, which I'll tell you later, will all go into both our conceptual models as well as the numerical models that we'll develop. Another really, I'm very excited about this part of the project. We are collaborating with Puake Nobelmeyer and Anoilani Aga from the Institute for Hawaiian Language Research and Translation on a whole other data set that we will bring into this project. We're very interested, for those of you, I hope folks know about this. If not, there was a recent news story about this, but the Institute of Hawaiian Language